A function f from x to y is injective if different inputs always give different outputs. So in other words, no two distinct elements of the domain map to the same element of the codomain. And so this can be formally defined as if f of x1 is equal to f of x2, then this will imply that x1 must be equal to x2. And maybe the easiest way to see this is with a small example. So let's consider here. Imagine that this is our domain and this is our codomain. And let's say that we have the elements A, B, C here. And in the codomain, we have the elements 1, 2, 3, and 4. 4 here. And suppose that the function is defined by mapping A to 4, B to 2, and C to 1. So this is our function f. And let's write a little table here. So for little x, let's have our f of x. And so when x is a, f of a is equal to 4. When x is b, f of b is equal to 2. When x is c, f of c is equal to 1. Now this function is injective, so this is injective. Why? So you can check that every element here in the codomain is the image of a single element in the domain. So one way to check this is you can see that if I take every element here, at least when I look at the diagram, if I look at the line connecting it, there's at most one line. So here there's at most one line, here there's 0 lines, which is at most one line, and here also at most one line, which means that every element in the domain can only come through the function from, so every element in the codomain can only come through the function from one element from the domain. And so it's okay to have elements in the codomain that do not correspond to any element in the domain, but you want to have a unique one in the codomain that corresponds to the domain. Another way of seeing this is if you're able to do a table like this, the column here with the f of x, all the elements are different. So there's no repetition here. And so that guarantees that the function is injective. Now, let's look at a different function. So let's say x again is going to be a, b, and c, and our y is going to be 1, 2, 3, and 4. And let's consider a different function. So let's consider a function that maps, say, a to 4, b to 2, and c to 2. And let's call this function g. Then this is not injective. And why is that? Oh, let's write a little table also here. So we have our little x and g of x. Let's write a little table here. So when x is a, so g of a is equal to 4, g of b is equal to 2, and g of c is equal to 2. Is equal to 2. So if we look now here on the right, if we do that test where we're checking how many things correspond to each element on the right from the domain, so 1, there's no issue. Nothing maps to 1, so that's okay. With 2, you have an issue. 2 things are mapping to 2, so here you can already identify that this function is not injective. So if I get if I know that g of x is equal to 2, I can't really know what x is. So again, if you look here, you'll see that there's a repetition here, right? And so another way of thinking about this is exactly in this way that we just said, which is if I tell you the output of the function, can I know what the input was? So that's another way of thinking of injection, and that's why we say also one-to-one, because it sort of assigns one to one in the domain to one in the codomain. And so if I look here, if you tell me what is the value of the output, so I will know exactly what the input is. So if the output is 4, the input is A. If the output is 1, the input is C. If the output is 2, the input is B. On the right here, that is not the case. So if you tell me that the output is 4, I will know that it's A. But if you tell me that the output is 2, I'm not going to know whether it's B or C. So it's not true that for every output, I know exactly what the input was. So, in other words, injective means that no repeated outputs from different inputs. And again, the main idea is a function is injective if each output comes from at most one input.